in our previous video, we computed the Riemann-Rover integral and of the capital fractional derivative. And we rather compared the beta function with our integral. So in this case, I just want to give a clear comparison, because in our previous video, I said the beta function and our integral are similar. So I just want us to look at it briefly before we look at other examples. Now, on my left hand side, we have the beta function, and on our right hand side, we have our integral. Now, let's put both of them in perspective. That's the beta function. Now we have u raised to the power alpha minus 1 into 1 minus u, close the bracket, raised to the power p minus 1. That's for the beta function. And then let me say for our integral, we have our u, in this case is raised to the power 1 into 1 minus u, close the bracket, 1, okay, excuse me, raised to the power negative half. So what we're going to do, we're going to compare these values. That is, our first u has a power of alpha minus 1. So let us equate them. And the second u, or rather let me put it in this form. Let me say we have u raised to the power alpha minus 1, which is still the same thing as u raised to the power 1. So what we are going to do right now is to compare these values. We have alpha minus 1 is equal to 1. So this clearly implies that alpha is equal to 2. Take note of that. We have here that our alpha is equal to 2. Now let's look at our this other value, because we're trying to compare the internal values. Raised to the power negative half. This one is for our integral, and if we equate it with the beta function, so we are going to equate the powers now. So we have minus half is equal to b minus 1. Now this clearly implies that our b is equal to half. So if our b is equal to half, then we have let me say b. We have b into a comma b, which is still the same thing as b into our a. Earlier we found, what did we get as the value of our a? Okay, or alpha. In this case we have alpha. So let's say alpha and b. So the value of our alpha is 2, and then the value of our b is 1 all over 2. Now, from the definition of a beta function, let's say beta function b alpha comma b, or alpha beta, whatever, is given to be this. We have this is the gamma of alpha, then gamma of b all over the gamma of, this is the gamma function of alpha plus b. Now we have the value of our alpha to be 2, and we have the value of our b to be 1 all over 2. So all we're going to do is just to substitute this value into what we have here. So in place of our alpha, we have 2, and the value of our b, this is the gamma symbol, we have 1 all over 2, which is half. Now, everything all over gamma of alpha plus b, which is 2 plus half, and this will simply give us 5 all over 2. Now, let's run through some of this basic idea of gamma function. Now we know that gamma of n is equal to n minus 1 close the bracket factorial. So let us use this idea now to solve the problem we have. So if we are to find the gamma of 2, the gamma of 2 now is going to be 2 minus 1 close the bracket factorial, which is still the same thing as what? 1 factorial, which is still the same thing as 1. Now, the gamma of half, let me write my half clearly. 1 all over 2, by definition, is the square root of pi. Yes, it's actually the square root of pi. And now, if we are to find the gamma of 5 all over 2, the gamma of 5 all over 2 is given to be 3 all over 2 gamma of 3 all over 2. Now, we also know that gamma of 3 all over 2 is still the same thing as half gamma of half, which is still the same thing as half of the square root of pi. Remember, we have talked about that previously, that gamma of half is given to be square root of pi. So now let's substitute this back into our original template, because earlier we started by saying, let me write this properly. Earlier we started by saying the beta function of this 2.5 is given to be this. Now we're trying to substitute back into, so gamma of alpha, or where is the value of our alpha, which is 2, is still the same thing as 1. From our solving, we have gotten it to be 1 earlier here. Gamma of 2, we got it to be 1. So we are substituting this back into our formula. So this is 1, and then gamma of b, which is gamma of half, is the square root of pi. Here is the square root of pi all over gamma of 5 all over 2. Now when we simplified, what we have is 3 all over 4, then the square root of pi. Now if we try to simplify this, here's what we're going to have. This goes with this, then we have 4 all over 3. This is what we have been using. This is what we used in our previous video, and that's the reason why we said the gamma function is similar to our integral. Thank you very much for watching.